So here we are now at this point in learning processing where we're at the sort of like bread and butter of learning to code. And this is the for loop. And the for loop is a function that allows us to iterate multiple times and makes our work a whole lot more efficient. So for example, say I wanted to draw 10 rectangles on the screen. I could do that manually. I could go in and I could say rect 100, 100 with 10 and 10. And I could Command C, Command V this on the next line and put this at 120 and Command V, I could do this 140, Command V, 60. Oh my God, this sucks. 80. All right, I'll do 5, Command V, and we'll get to 200. All right, so you can see I got to 5. I got to 6 pretty quickly here. But imagine I wanted to do this, but I wanted to draw 100 of these. This act of writing each one out is just not efficient. And if I wanted to change one tiny detail, I would have to go back into each individual element and change it. So what we can do is use something called a for loop. And a for loop is written like this: for, and it takes an initialization, a test, and an update. And you could think about this as 3 different statements. Put this on the next line. And this is actually followed by some brackets. And we're getting an error because this is not exactly how you write it. I'm using pseudocode. So this initialization is where do we want our loop to start? Because a for loop is a set of instructions that happen over and over again until an object turns false. And so here we set it up and we say, I want to make a variable equal to 0. So I'm going to say int for an integer. I'm going to call it test equal to 0. You can call this whatever you want. Most of the times when you're seeing this in a textbook or online, you will see it as the word I. But just for our sake, I'm going to call this like our test. I want test to be equal to 0. And then I'm going to say, I want this to run 10 times. So as long as test is less than 10, keep going. But I need to tell test to change somehow. I need to give it some sort of update to say, hey, test needs to increase in value. And so I'm going to write test equals test plus 1. So every time this for loop runs, it's going to add 1 to the value of test. So the first time that this runs, and we can just look at this. Let's just, inside our for loop, I'm just going to write print the value of test. And we can see this down here, right down here in the console, and that's super tiny. Let's make that a little bit bigger. So let's look at my console font. Let's make this 24. Let's run this again. So down here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it starts at 0 and then goes up to 9. It's not going to equal 10 because it's when it's less than 10. And it's doing print because print goes on the same line each time. I could do something here that says print ln, and that will do it on a do line every time. We can see this happening down here. So the value is increasing by 1 each time it runs because test is equal to test plus 1. So the first time this runs, 0 plus 1 will equal 1. The second time this runs, it will go through, test will be equal to 1 plus 1 equals 2. So if I change this to 2, this will only run 5 times because, let's drag this up, 0 plus 2 plus 2 again would be 4, add 2 to this would be 6, add 2 to this would be 8. So this whole for loop will run only 5 times. So depending on how you change the update function or the update argument inside here, that will change A, how many times your test runs, and B, the sort of difference between each version. Inside these curly brackets is our statement. That's what we want to have happen. So here, I'm going to actually set this back so it's a little bit more organized. This is usually how a for loop will look. We'll say for, a variable will equal 0. We give it a test case. So we say we want to say how many times we want it to run, and then we give it an update. I'm going to bring this back to 1. Now let's draw the same rectangle that we had before. Command C, and I'm going to comment this out, or put this here. And then instead of writing test, I'm going to write here, rectangle drawn. So this is going to print a line saying the rectangle has been drawn. So when I play this, we look down here, this is now telling us we've had this run 10 times. We've drawn 10 rectangles to the screen. Right now, we're seeing some of these other rectangles, so it's actually a little hard to see. So let's comment these out, run this again. And right now we're only seeing one rectangle. And that's because all of them are being drawn right on top of each other. So let's move them a little bit. One way we can move them is by saying we could use the value of test to change it, because test is going to change every time. So I could say 100 plus test, run this again. All right, now we're seeing a little bit different. What's happening here is we're seeing the stroke move. We're seeing the outside of the black stroke, and we're seeing this move over by 1 pixel each time. And because the stroke weight is equal to 1 by default, we're only seeing the outside black line. So let's actually do test times, we'll do test times 4, and we'll be able to see a little bit of a difference. And remember, order of operations, whatever happens inside the parentheses is what happens first, and then you have the argument on the outside. I'll run this again. Oh, there we go. Now we're seeing some more lines. But what's happening here is each of these shapes is 10 pixels wide, and we're multiplying test by 4, which would be start at 0, then it'd be 4, then it'd be 16. Then 8, then 16. 8, then 12, then 16. Oh my God. And so we're not seeing it move over enough. So if I did times 15, which is greater than the width here, run this again, now we'll see a little bit of separation. And we're seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over here. So if I wanted 20, all I have to do is change this test case, as long as it's done less than 20, 50. And this is where variables might be a little bit helpful. So instead of using this test, which can be a little bit strange, I might do something called float mover. So I'm going to make a new variable equal to this test times 15. Semicolon at the end, and then I can do 100 plus mover. Same thing, just makes it a lot more easy. If I wanted to increase the width, or actually let's increase the height each time this runs, plus mover, I can use it in multiple places. Cool. The reason this is happening is instead of going from the center, remember rectangles are started at the top. So if I want to change this so it looks like it was, increasing out, I could do rect mode above this. And center. Oop, semicolon. And now they're going to increase out in size. I could do the same thing with this. I could do divided by mover. Oh, this will get a little weird. All right, yeah, it's getting too small, right? It's going below 0. So that doesn't work. But you kind of get the idea where you can play around a lot with this. One other cool thing you can do is you can also use random in this as well. So this is running 50 times. I'll change these back to 10 and 10. You could make x equal to random. And if I did random width, or let's do random 600 just to start out, which is the same as our width. And I did float y equals random 600 as well, which is the same as our height. And I drew this at x and y. Every time the for loop runs, it's going to give us a new random x and y location. So we're going to fill our canvas with a random sketch, a random design each time this runs. What if I did it with 100? Totally filled. What if I did it with 1,000? Run this again. All over the place. What if I went in and I did fill? I'm going to make a new one for color. So float COL for color. We don't want to use color as a variable name because it's the same as a default value, our built-in function. So I'm going to use col. So random 255. And now if I use this for fill COL, now each time this runs, this for loop runs, it's going to give it a random color and a random position. All right, now we're getting some snow. I could go in and say COL here and then 0. Now we're getting these like yellow ones. So you can get a lot of sort of variation inside here. It doesn't have to be rectangles, it could be ellipses. You know, if this was inside a draw loop, it would keep running and it would be animated, but for our purposes, we're just drawing to the screen for right now. I'm gonna turn off these guidelines so we can see it a little bit more clearly. Oftentimes, one last thing is you will see often this written like test plus plus, or it'll actually be I is less than 0, or I is equal to 0, I is less than whatever number you're using, and then I plus plus. And this is the standard sort of way. So you declare it, you give it a test, and then you give it an update. And this I plus plus is the same thing as I equals I plus 1. Let's look at 10,000. All over the place. One thing is this print. Whenever you print, it slows it down a little bit. Right? If you gave each one a little bit of opacity, right? You could give each one some roundness. Let's do no stroke on this. See, and this is where you can start to have fun in terms of making these designs. Oh, that's nice. It's like a little cloudy sort of feel. It starts to feel biological in a sense. Neat. What if we kept going up? How long till it stops? All right, still keeps going. So you can do a lot of high-end processing with this. And do one more number and then call it a day for loop. All right, very nice texture. That's, I think, maybe too big for right now. But I think you get the idea. Because this for loop runs as many times as we have the test case, we can tell it to do a set of instructions inside of it, either randomly or tell it to move or increase. One last one is if I used the value of I to increase the ellipse. So if I did an ellipse at width divided by 2, height divided by 2, and then I did I times 10, and then I times 10 here, we'll get a radiating circle out. Let's just do 10 here. So if I is less than 10, right now they're all overlapped on top of each other. So let's do no fill. So you can start to see those radiating out. Change the value to 100, goes out way more. Eventually, you can take these designs and bring them directly into Illustrator if you export as a PDF, because they're all vector-based. It's all based on math, so it's based on the system of coordinates. But this is the basics of working with a for loop.